Now we're going to look at some mixture problems that are percentage mixture problems. And these are very similar to the ones that we've just done, except now we're going to use percentages. So let's take a look here at our problem. It says a health food store sells seasoning blends in bulk. One blend contains 20% basil. So I'm going to put 20% in this bucket. All right, let's go on. She wants to add pure basil. Well, pure basil would be 100%. She wants to add pure basil to some 20% blend to make 16 ounces of her own 30% blend. So I got 16 ounces of a 30% blend. So my mixture here has 30%. And my mixture is 16 ounces. Then it says, let B represent the amount of basil Sheila should add to the 20% blend. Okay, well, that would mean my variable B would be in my 100% bucket. Let B represent the amount of basil Sheila should add to the 20% blend. So now how many ounces of the 20% blend am I going to use? Well, if I got a total of 16 and I've got a variable here of B, well, this is going to be 16 minus B. Okay, so I got my buckets filled out, and I should be able to write my equation. And you could use the decimal form of the percentages, or you can just use the percentages themselves. It doesn't matter. I like to use the percentages as they're given because then I don't have to convert the decimals back. I don't have to convert from percentages to decimals and then from decimals to percentages. It does give me some bigger numbers as I'm working with it, but that's okay. So let's see. I've got 20 times 16 minus B plus 100B equals 30 times 16. Okay, so there I've written my equation. 20 times 16 minus B plus 100B equals 30 times 16. All I did was just take my information from my buckets and fill out my equation. Now, how many ounces of basil, she's talking about the pure basil, should Sheila use to make the 30% blend? That's why we set the variable to B. So let's go ahead and start working with our equation. Now, first I've got to distribute this 20 here to both the 16 and the B. And so when I do, I'm going to have 20 times 16 is 320 minus 20B plus 100B. Nothing's changed with 100B equals 30 times 16, which is 480. All right. Now I'm going to combine my like terms. Well, I'm going to subtract this 320 from both sides. And when I do, I'm going to get 160. 480 minus 320 is going to give me 160. And I'm going to combine my like terms here. I got minus, don't forget to minus out here, minus 20B or negative 20B plus 100B. Well, that's going to give me 80B. Now, I'm going to divide both sides by 80. So it's going to cancel over here. This is going to cancel. It's going to leave me with B. Let me go to a different color that we can see. So that's going to give me B. And when I divide 160 by 80, that gives me 2. Okay. So that's telling me that the number of ounces of the pure basil used to make the 30% blend, the answer to this question right here, is 2. And then lastly, it comes back and says, well, how many ounces of the 20% blend should you use? Well, I go right back up here to what I set to begin with, and I just simply take 16 minus 2 equals, I substitute 2 in for B, equals 14. And so I need 14 ounces of the 20% blend to 2 ounces of the 100% Basil to give me 16 ounces of a 30% blend. That's not too bad. Well, let's look at another percentage mixture problem. All right, so here we've got whole milk is 4% butterfat. How much skim milk with 0% butterfat should be added to 32 ounces of whole milk that is 2.5% butterfat? All right, well, I got this bucket here on the left, and I'm going to label it as my 4%. All right, and then I've got skim milk, which is 0%. And should be added to 32 ounces of whole milk. Well, my whole milk, which was this 4%, is my 32 ounces to obtain a mixture that is 2.5%. 2.5% butterfat. Okay. So I got 32 ounces in my first bucket, that's 4%. How much skim milk? Well, that's going to be my variable. So I got X here in this bucket. And as far as the volume of my mixture of the 2.5% butterfat, well, it's just simply 32 plus X. Okay, so that 0% butterfat may look kind of strange right there, but it's going to work out. Now, I've got my buckets filled out, and I am just going to write my equation. So I got 4 times 32 plus, close my parentheses, 0x equals 2.5 times 32 plus X. All right, well, let's begin to solve. Well, 4 times 32 is 128. And I'm going to go ahead and keep my 0x here just as a placeholder. I don't really have to have that. Now I'm going to distribute the 2.5 times the 32 and the x. And when I do distribution, I've got to distribute it against both of the terms inside the parentheses. So 2.5 times 32 is 80. And 2.5 times x is 2.5x. All right, so I'm going to combine all my like terms. Well, obviously, I've got 0x right here. So it doesn't matter if I add or subtract. And I'm going to leave my x's over here on the right since I've got a positive over there. But I am going to subtract this 80 from both sides. And so that's going to give me 48 equals 2.5x. Now I'm going to divide 48 by 2.5. And once I do, I'm going to get 19.2 equals x. Let's see if I'm done. It says how much skim milk with 0% of the butterfat should be added to 32 ounces of whole milk. Yeah, I'm done. I need 19.2 ounces of skim milk added to 32 ounces of whole milk to end up with a mixture of 2.5% butterfat. 19.2. That wasn't too bad at all. Well, certainly I don't want to leave you without a problem to solve. So let's see what we got. We're working on percent as mixture problems. And we got, here's our problem. How many grams of sugar must be added to 60 grams of a solution that is 32% sugar to obtain a solution that is 50% sugar? All right, we're going to have 3 buckets just like we always have. Now, when it says how many grams of sugar, well, that means it's 100% sugar. It's just sugar in granulated form. And then in our second bucket, we've got 60 grams of a solution. That tells us the volume. And it's 32% sugar. And then our mixture is a certain volume. We don't really know how much, and we're not really asked to find out how much. We just want to find out how many grams of sugar is needed to give us a solution that is 50% sugar. So you're going to want to set up your buckets, write your equation, solve for your variable, and your variable is going to be the grams of sugar needed. I'll give you that tip. So let me give you a moment or two to write this problem down so that you can get your buckets filled, write your equation, and then solve it. Well, by now you should have had an opportunity to write your problem down. If you're watching this online, obviously you need to reply or make a comment or make a comment, give me the answer. And if we're in class, well, I'll just be expecting you to work on the problem and have the answer ready should and when I call upon you.